So to find the Hamiltonian, we need to know the energies of every single eigenstate. So again, from equation 2.30, we know that En is equal to n squared pi squared h bar. Now note that from our value of psi, now if you recall, this is our C1 and this is our C2 that you've seen before in your chapters. And you've seen that C1 squared or Cn squared corresponds to the probability that you're in the nth state. So that means that the first state will have a probability of 1 over square root 2 squared, and the second state will have a probability of 1 over square root 2 squared. And a good check to just make sure is that when you add all your probabilities, they should add to 1. So what you'll find is that the probability of the first state is half, and the probability of the second state is also half. So we found the energies. Now the only thing left to do is to find the Hamiltonian. So here you can use equation 2.41. That's because all the other states are going to have zero probability, as we showed earlier. So it just leaves these two states. And we have all those values, so we're going to find that it's equal to half times pi squared h bar squared over. Now the important thing to note is in your solutions it says you just take the average of those two, but that's actually not true in general. The only reason you can do that is because the probabilities are the same. So what you need to do in general is use this equation, use equation 2.41, so if you get another test or something, and then you're going to have to find the probabilities associated with them. Because a common test question is they'll give you 3 states, but the probabilities will be C1 is equal to 1/4, C2 is equal to 1/4, and C3 is equal to half. So then when this is true, then you can't really just take the average like your solution manual does. You're going to have to apply this equation. So try not to think of it as an average. Great, so that's all I got. Thank you very much.